A new study suggests that glass beads on the Moon's surface could provide an easily accessible water source for future missions. Key point: scientists analyzed glass beads collected by the Chang'e-5 mission. Scientists analyzed glass beads collected by the Chang'e-5 mission. An international team has analyzed lunar glass in soil samples brought to Earth by the China Chang'e-5 mission. Researchers led by Huicun, the Chinese Academy of Sciences, estimate that between 300 billion and about 300 trillion kilograms water are trapped in tiny glass beads scattered on the Moon. According to their analysis, published today in Nature Geoscience, water is formed from hydrogen given off in a stream of charged particles flowing from the Sun, called the solar wind. These findings suggest that the lunar soil contains much greater amounts of solar wind-derived water than previously thought, they wrote. This suggested that the beads play a central role in the Moon's water cycle and could be an important reservoir for space bases. Finding water in the ocean of storms. The Moon was once thought to be dry, but in the last 20 years orbiting spacecraft have detected hydrogen and ice in deep craters at the lunar poles. In 2020, a team of NASA scientists detected water molecules in sunlit regions of the Moon for first time. They suggested that it could be trapped in glass beads, which explains why the water does not evaporate. Clues of water have previously been found in glass from samples collected by the Apollo missions 40 years ago. In late 2020, Chinese Chang'e-5 became first spacecraft to return to Earth with rocks from Moon since Apollo era. The Chang'e-5 landing site location was compared to the US Apollo and Russian lunar sample return sites. Planetary scientist Craig O'Neill at Queensland University of Technology, who was not involved in the study, said Chang'e-5 landed in the Ocean of Storms, a geologically unique area that has not been sampled before. This is an extraordinarily radioactive part of the Moon. It's also close enough the equator, it gets enough sun, so water will need to be bound in a mineral be stable. Glass beads are formed when micro-meteorites smash into the surface, melting the rocks around them. Previous analyses dating age of beads collected by Chang'e-5 spacecraft showed that area had been arded in last 2 billion years in a process known as pulse garden. How does the solar wind create water? They are porous enough to absorb hydrogen transmitted by solar wind, while any water squirts out of beads at initial impact force. The hydrogen interacts with the oxygen trapped in the glass to form hydroxyl, an ion that can bond with more hydrogen to form water. Hydrogen is like intruders at a party, said Dr. O'Neill. They go in and then they connect with the oxygen atoms in the mineral. For this study, the team blasted 32 beads with a laser that looks for traces of hydrogen isotopes. Higher hydroxylwater concentrations were detected in the Chang'e-5 beads than were found in samples collected by the Apollo missions. One of the lunar soil samples taken by Chang'e-5. As the beads are constantly arded by the solar wind, water accumulates. Cross-sections of 5 spheres revealed more hydroxylwater on outside of glass than in center. The solar wind is beaming outside of these beads. So basically you're creating the water outside, and it's spreading towards center. The analysis showed that water formation was relatively rapid, and only took about 15 years to reach the levels detected in the beads. The Chang'e-5 team speculated that water could be released into space as vapor heat from the Sun, or by being struck micrometeorites. There are different types of glass beads on the Moon. Chang'e-5 analyzed the impact beads, while volcanic beads were found in the Apollo samples. The idea that beads play an important role in the Moon's water cycle is very plausible, said Marc Norman of the Australian National University. Having previously worked on beads from both the Apollo and Chang'e-5 missions, Dr. Norman said higher water concentration in the Chang'e-5 sample compared to Apollo samples could be due to different rock types. Apollo beads are volcanic glass, while Chang'e-5 beads are impact beads. Many of Apollo missions went into impact craters and are drilled into the deeper subsurface, so many samples probably wouldn't have been exposed as long as Chang'e-5 samples. A big deal for compromise. Planetary scientist Phil Bland of Curtin University, who was not involved in research, said it would be a really big deal for space exploration if the water in beads turned out to be easy to reach. The more accessible resources you can find on the moon, the more likely we are to develop a permanent settlement, said Professor Bland. Chang'e-5 returned to Earth with about a kilogram of moonstone. The question is how much water is in the beads, and how easy will it be to remove? Previous analysis by Chang'e-5 team on lunar dirt, or regolith, revealed that the beads contained more water than surrounding soil. Experiments by the Chang'e-5 team showed that it is relatively easy to release water from the beads at lower temperatures using very low technology. You heat it up to few hundred degrees, and with a condenser at the top, you can draw water out of these beads in fairly simple process, said Dr. O'Neill. So for future on-site resource planning, this is big step forward, marking the way to a resource with fairly high water content. We're not talking about quantities, about something like the world, but enough to use it. But Dr. Norman was not convinced. The fragments are small, and there is usually only a modest amount in the soil, so extracting them on an industrial scale for on-site sourcing may, at least at this point in time, be overstating their potential importance.